Hi, thank you for the one person listening. Okay, I know this is difficult for Swedes, but you are allowed to engage with the speaker. Yeah? No, you're not Finns. What is the difference between a Swede and a Finn? I'll tell you, a Swede is someone that looks at your shoes while they're speaking to you. That's it, there we go. Good, good. I have Finns in my family, but they're currently several hundred miles away, so they can't ding me for that. Hello, good afternoon, everyone. I am amazed that so many of you would stick around for this session. Are your heads not already crammed with useful stuff over the last couple of days? Mine certainly is. So I had a theory. So Matthias kindly asked me, would I do the closing session for Jfokus 2023? And I've been to Jfokus before. I was here in 2009 talking about the intersection of agile methods and RESTful distributed systems. Here again in 2014, talking about graph theory of all things. And I thought, yeah, I'd love to come back. And I thought, but why would you want me to do the closing session? And I had a theory, and the theory is he simply wants me to clear the room quickly so that the venue staff can get on with their job. Right? And I think that theory has now been not disproven, but it's been augmented. He wants me to do the last session so that I didn't spoil his beautiful poll numbers. Right? That's it. That's the real reason that he wanted me to be here. So I'm going to talk a little bit about AI. I'm coming at this from a systems and data perspective, but I think this kind of wave of AI, particularly since the inception of ChatGPT, it's impacting all of us, right? In my career, which sadly now is looking at that guy on the screen, wow, he's a tenured career professional at this point, right? He used to be a young, enthusiastic person. Now it's this old geezer that we see up on the screen there. Man, that is a horrible angle, right? So in my career, I've built various bits of systems, but none of them have ever attracted, politicians to legislate. None of them have ever had such, yet, lady in the front sniggering. I am not some kind of terrible cyber criminal. None of them have ever attracted the kind of worldwide attention of politicians to legislate for the use of this technology in the way that AI has. So I think for all of us, whether we are directly involved in AI systems or not, it sort of makes sense for us to have an idea of what's going on in this world. And in fact, to be able to separate fact from fiction. Now, 2024. It's a fun year. When I was a kid, which apparently is a long time ago, I keep looking at this screen now. There's another old guy on this screen. God damn it. When I was a kid, things like newspapers and so on had an air of trustworthiness about them, right? Now, whether they were leaning towards your side of politics or away from your side of politics, it wasn't so important because you generally trusted them to say factual things, right? And there was a kind of journalistic tradition of that, which is somewhat waning in modern times with the kind of people looking to get the next click, the kind of the engagement from the internet, to the point where fact and fiction are sometimes hard to discern in the real world. Fact and fiction is definitely getting harder to discern online. So there is an American politician who's quite a radical person, and she tweeted to a rather large base that anyone who votes to fund Ukraine is funding the most corrupt money scheme of any foreign war in our country being the US, history, and forcing the American people to pay for it. I mean, that's shocking, right? I mean, imagine if you, for example, wanted to contribute to the armed struggle of Ukraine, but actually your money was being siphoned off for criminal reasons. I think if I read that from a politician, I would be, wow, not shocked, right? It's a shocking thing. It turns out that was bullshit. She perhaps legitimately, perhaps unknowingly, retweeted a disinformation campaign that stemmed from Russia. So Russia has this rather sophisticated hybrid warfare skill, right? And plants the right seeds, watches them grow through the networks. And ultimately, Marjorie Taylor Greene retweeted or tweeted about something that was definitely lies. Now, I don't know if you've noticed, but 2024 itself is it's a kind of important year, right? There's a few factors that are kind of overlapping in 2024, a confluence of a few kind of worrying things. So we're seeing the rise of AI, right? So we're seeing not just the ability for bad actors to use convincing misinformation on the internet, so using AI to produce things that could mislead us but in a convincing way, but we're also seeing the confluence of elections around the world. In fact, tomorrow, Pakistan goes to the poll. Pakistan, of course, a nuclear power. Later in the year, India, the world's largest democracy, also a nuclear power, goes to the poll. Perhaps more worryingly for you, this year the United Kingdom goes to the poll. If you haven't heard of the United Kingdom, we are a nuclear-armed madman off the coast of Europe, currently enduring an incredible midlife crisis. I think, and I don't think I'm wrong on this, if one of our crackpot politicians offered to run on the manifesto of Nuke France, they would have a legitimately good chance of getting in. Also, we know which way the prevailing winds go. So once we've nuked France, you get the fallout. Yeah? You thought our acid rain was bad, you wait until 2024. But of course I kid, because the big game here is the presidential elections in the United States in 2024, widely considered to be the first AI election, for good or for bad. So with AI, all of this stuff gets scarier. We know that we can use, and we will be using, or people will be using AI to create information and misinformation. But more chillingly and practically, sometimes we use AIs and we just don't know that they're creating misinformation or hallucination. Let me ask you a question. What is this? It has been extensively trained on a wide variety of eclectic subjects. It answers confidently, even when it's making stuff up. It's opaque about reasoning, and it's very expensive. Anyone got ideas about what this might be? This, by the way, that was a clue that you interact now. ChatGPT, AI, any more? Oh, wow, now you're all interacting. This was unexpected. Swede overload exception. Wait, somebody wins the prize. Of course, this is former Prime Minister of the United Kingdom, Boris Johnson. He has been extensively trained, he's a classicist, on a wide variety of eclectic subjects while he was at Eton and while he was at Oxford. He answers very confidently, even when he's making shit up, which is practically always. He's opaque about reasoning. He's a politician, and he's damned expensive, according to his parliamentary reports. No, of course, I did mean ChatGPT. But one of the things that Boris and ChatGPT have in common is they don't seem to know when they're making things up. Boris Johnson is the only Prime Minister of the United Kingdom that has ever been found guilty of a crime while in office, right? I mean, in previous years, this would have been a massive scandal, but our standards have slipped, sadly. Recompose. But I find this hard to say, particularly in front of an audience, so support me here. But I feel sorry for Boris Johnson, right? Any Brits in the audience are like, what the heck? I do, because I genuinely, when he's speaking and he's holding forth on a topic, and he's saying things that may be true or may not be true, I genuinely don't think he can tell the difference, right? And I think when people accused him of being a liar, you could see in his face he was hurt, right? Because he doesn't think he's a liar. He's provably a liar, by the way, right? That's in both the parliamentary and the criminal record system. He's a liar, but he doesn't know it. And our AIs are the same. You call it hallucination. I call it Boris Johnson effect. Trademark. So let's have a look. Let's have a look, shall we? Let's have a look. So this is an experiment with ChatGPT. Actually, I borrowed this from a lady called Yejin Choi from University of Washington. We'll come back to her. She's a very important actor in the way that this rolls forward. If it takes 5 shirts, 1 hour to dry in the sun, how long will it take 10 shirts to dry in the sun? Sorry? 2 hours, thank you. And if it takes 5 shirts, 1 hour to dry, ChatGPT tells me you can set up a proportion to find out how long it would take for 10 hours to dry. And it does a bit of arithmetic for me, right? So whoever said 2 hours in the audience, ChatGPT agrees with you. Now, of course, that can be true in some circumstances. If you dry 5 shirts, bring them indoors, and then dry another 5 shirts. But of course, assuming that I have a garden that's big enough for 10 shirts, it takes 1 hour. But look what ChatGPT does here. It writes some convincing text, Boris Johnson style, to convince you what it's saying is right. And it's not right? Because the answer, within certain plausible model conditions, is 1 hour, right? Because the sun is practically infinite. It's not like one shirt takes too much energy from a neighboring shirt, right? And assuming I've got a garden, I don't know, 1, 2, 3, like the length of this stage, so, okay, a modest garden, I can do this in 1 hour. Now, that's fine. ChatGPT says the wrong thing and tries to convince you it's right, right? The Boris Johnson effect. My boss, who some of you may have seen about 4 years ago here at Jfokus talking about the Panama Papers. So my boss, Emil Efrem, he's the CEO of Neo4j. So we're a Swedish company based down in Malmö. So when I say we're Swedish, kind of half and half, really, right? From the point of view of Stockholm, we don't exist. From the point of view of the rest of the country, we're basically Danish. So my... Oh, I do love meddling in regional politics. So I only just learned that the good people of Skåne once a year have a tradition where they take levers to the edge of the county and they try to lever it away from the rest of you, right? This is just amazing. Because from the point of view of like everyone else in the world, we can't tell you apart. You might as well be Norwegian. We can't tell. Anyway, so my boss, Emil, asks ChatGPT, who is Emil Efrem married to? And ChatGPT gives an answer, not just who Emil is married to, but when they got married. Emil is married to Johanna Efrem in 2011. Cool, okay, seems reasonable, right? I mean, from my point of view, the names match up, right? There's now a kind of family name that matches. So that's awesome, right? So let's move on. You know something, oh, wait a minute. In Sweden, sometimes you adopt your partner's name when you marry, right? So that's one way that you can share a name. Yeah? Anyone think of another way that you might share a family name? Sister! Close. Daughter! Oof! Dude! Actually, in this case, Joanna is Emil's cousin. Madeline is Emil's wife. And it wasn't 2011 either. So again, ChatGPT comes up with a load of convincing stuff. It doesn't know it's lying. If I hadn't made these kind of awkward jokes about Emil and his relationships, we wouldn't know it's lying. The person that knows it's lying is Emil, and probably Joanna, right? But the rest of us, we'd be convinced by this, right? Yeah? Yeah, nice, nice. So, cool. So look, I'm here to tell you a story. And my story hopefully starts with something less awkward and a bit more deterministic and absolutely a little bit more British. Yay! It's like playing on at your home stadium now. Doctor Who, right? Who knows Doctor Who? Come on, give me a wave. Oh, you are awesome. I tried this in America and people are like, Dr. What? I'm like, who, not what. So that came out as kind of like Eric Cartman then, didn't it? I didn't intend for that, Dr. Watt. So Doctor Who is the longest running science fiction TV show in the world. Apologies to the chap that I talked to earlier with the Star Trek t-shirt. Star Trek is awesome, luxury space communism, I'm with you. But Doctor Who is the longest running sci-fi show in the world. And it started back in 1963, and it is centered on this fella. Well, sometimes a fella. In this case, it's a fella. This is the 12th Doctor, played by Matt Smith. Now, clearly, Matt Smith played the character of the Doctor much more recently than 1963. And what the BBC have is, when they started the show, they found it was unexpectedly popular. In fact, truthfully, it was never really meant to be a sci-fi entertainment show. The BBC have this mission statement, and it is to educate and entertain. And so Doctor Who was originally created as an education show. And the Doctor, Matt Smith in this case, but played by many actors over the years, the Doctor could go forwards and backwards in time, and the intent of the show was actually to sneakily teach British children history. because otherwise we wouldn't learn, right? We'd be reluctant. But you give us like some guy in a time machine, and suddenly we're cool. So anyway, so the Doctor has been played by lots of actors over the year. This is the 12th Doctor. We've now moved on. The current Doctor is a fabulous young actor called Nakuti Gatwa. And so a lot of you know Doctor Who, so keep me honest. But for those of you that don't know Doctor Who, you're about to learn it. The excitement in the audience, right? So this is Matt Smith playing the Doctor, and it turns out I can tell you some facts about the Doctor really easily. So the Doctor is not human, although he looks human. He's actually a Time Lord, so he's humanoid. Many of the characters in Doctor Who are humanoid because the BBC has a very small special effects and wardrobe budget. As a public service broadcaster, they have to keep the costs down. But the Doctor is from planet Gallifrey, so he's an alien. And the Doctor, a long time ago, back in 1963 in our time, he stole a machine. He stole a machine that can travel in time and space. It's called a TARDIS. And for historic reasons, this blue thing is a police box. So in the old days in the UK, we used to have phone boxes for public calls, but there were also police boxes where the police could kind of use to kind of communicate with each other because we didn't have like radio comms back in the day, right? So he ends up stealing this machine, called a TARDIS, and he can now travel in time and space. And in fact, he's a do-gooder. He goes around the universe putting right things that have gone wrong, and he makes enemies in doing that, right? He makes enemies of bad guys. This is, of course, the famous Dalek, actually the second enemy that the Doctor faced, and truly terrifying for children in the UK. We'd hide behind the sofa away from these things, even though they cannot climb stairs. Yeah, so if you're ever accosted by a Dalek, walk upstairs. Well, the Doctor made enemies of these folks. This is the Cybermen, made enemies of these folks. This is the Sontarans. And also the Doctor makes friends. The character of the Doctor is quite a needy person and often travels with people called companions. So this is Rory and Amy, so from a few seasons ago. And actually, Rory and Amy have got their own thing going on, right? They love each other. Isn't that sweet? Notice, nerds, loves. You see that Rory loves Amy? Yep. And Amy loves Rory. Yeah. That's the way love works. Yeah. Now, I know you've got a crush on that hot person in the office, but they don't know you exist, okay? That's an asymmetric pattern in the graph. I'm sorry. We've all been there. I'm with you, nerds. But this is how actual normal human loves works. It's bilateral. Oh. Now, of course, there is a real-world aspect to Doctor Who, right? Look, I'm not having a nervous breakdown. I know it's a fantasy thing, right? I'm not saying that Doctor Who is real, but there are real things. There are the episodes that we watch. There are the scripts, the actors, the locations, all of that thing, all these physical things that can also be also be mined for facts. And in this case, I can see that the Doctor has appeared in Victory of the Daleks. I can see that Rory has appeared in A Good Man Goes to War, all this kind of stuff. And if I slap a few labels onto this, I've actually got a rich, high-fidelity model of facts. Yeah. So I can see that character Amy appeared in Victory of the Daleks. I can see that the Doctor appeared in Victory of the Daleks, that kind of thing. So I can ask you a question, particularly for those of you that are very, very new, maybe a few minutes old to Doctor Who. In which episode did Amy battle the Daleks? And you can kind of move your fingers over the links, and you can find, oh, look, Amy is a companion of the Doctor, who's an enemy of the Daleks, so they're enemies, cool, transitive enemies. And then Amy also appeared in Victory of the Daleks alongside the Daleks, so that's the episode that I might want to watch. Yeah, easy. This is deterministic, it's factual, it's transparent, it's curatable. Yeah, it doesn't lie, it's just a bunch of facts. I mean, you could pollute it with lies, but that would be an explicit choice that you would make. So I've got this structure, this knowledge graph, which I can mine for facts, right? Cool. Let me tell you about another situation. Anyone recognize this chap? David Cameron, thank you, sir. David Cameron, former Prime Minister of the United Kingdom. Anyone know what he's famous for? Avatar, Brexit, Avatar. You're not making my job any easier, mate. Come on. Famous for Avatar. Also, in between directing movies, famous for Brexit. Now, look, I told you that the United Kingdom, where I have the misfortune to live, is having some kind of midlife crisis, right? We are an nuclear-armed madman off the coast of Europe and to be treated accordingly. But let me tell you the sorry story about how we got here. This is David. David went to Eton and Oxford. He's a very accomplished figure. And he is friends with George Gideon George Osborne. Whichever. George Osborne. They were chums. Notice again, bilateral friendship. So they're chums. Posh people don't say friend, they say chum. I don't know why. It's a peculiar British thing. And it turns out that George was minded in the aftermath of the financial crisis to create a policy of austerity in the UK. So cuts to public services in order to be able to reduce the national debt, which had been inflated, kind of bailing out the global financial system in 2008. And concurrent to that, I can't believe you know this guy, right? I can't believe that I was willing to explain who this guy is, but since you laughed, you already know who he is. This is Nigel Farage. He has 7 times tried to be an MP, Member of Parliament in the UK, and has failed 7 times. Right? Let that sink in. That's how popular he is. But the Conservative Party, the Blue Party, of which George and David were members, were kind of scared of this guy, right? Because he was running this kind of populist campaign. And so David decided that in order to defeat the thing that Nigel was on about and kind of calm the discontent in his own ranks, that he would do this Brexit thing, and David thought, I'll call a referendum, I'll win the referendum, because I win at everything, I don't expect to lose this, and then that will be that. Nigel Farage could go away, the people who were getting a bit crazy on the right of my party will settle down, and we'll get into the business of government. Now, I also think that the fact that the substantial increase in poverty in the United Kingdom also led to this kind of feeling of unease and kind of the fact that politicians weren't serving us well, the system wasn't working. So I think you've got this kind of dual thing in this knowledge graph. So austerity led to Brexit. David, of course, famously called the Brexit referendum and surprisingly lost it. I have to say, waking up the morning after that referendum was just like, very unexpected and hard to process, right? Yeah, very much so. David then, of course, having been somewhat humbled by the result, rather than doing the grown-up thing and saying, well, I'll sort this out now, just say, oh, see ya, I'm out. And he was replaced by a lady called Theresa May, who you may have heard about. And she was determined to improve her mandate. So she called an election to try to get her own mandate in Parliament, rather than being just literally David Cameron's successor. And she was faced off against this chap. He's called Jeremy Corbyn. He's kind of like Bernie Sanders of Britain, right? So he's on the left of politics. And it turns out that although Theresa May defeated Jeremy Corbyn, he demolished her margins and left her with an unworkable majority in Parliament, quite unexpectedly. So she was then subsequently, remember this guy? Subsequently succeeded by Boris Johnson, who smashed Jeremy Corbyn again in 2019 and sent Mr. Corbyn back to electoral oblivion. But then, of course, Boris broke the law by both in terms of the COVID lockdown, and there was some dodgy money that went his way. This is not your local Indian restaurant, by the way. This is his living room, which a shadowy donor gave him free money for. Like, honestly, if you folks want to give me free money, I will not squander it on this, right? Oh, my word, that is dodgy. So then he came out of politics because, reluctantly he was found to have lied and it was causing trouble. And he was succeeded by a lady called Liz Truss. Have you heard of Liz Truss? Yes, you have. Blink and you miss her. So she was influenced by this kind of dark money think tank called the IEA, promoting a very kind of radical agenda of free market capitalism, like, sell your own children, free market capitalism kind of stuff. And she wasn't very successful because she immediately lost the faith of a bunch of left-wing commies called the bond market, right? So she was so free market capitalism that the actual free market rejected her, right? Which is odd. One of the newspapers ran a campaign. They bought a lettuce from a supermarket, put some googly eyes on it and a wig. and said, will this lettuce last longer than Liz Truss's prime ministership? And it did. Holy crap, guys. Oh. All right, that, I can't tell you what an emotionally exhausting thing that is. Finally, we now have the current Prime Minister, Rishi Sunak. He is our first Prime Minister of color, comes from a South Asian background. In order to get Rishi Sunak voted in as Prime Minister, he first had to become leader of the Conservative Party. In order to do that, they had to change the rules so none of the party members could vote. Let that stick with you, right? And here we are. So, in both of those knowledge graphs, we talked a lot about facts. And I looked up in the dictionary yesterday because I thought I'd better do my homework. A fact is a noun, a thing that is known or proved to be true. He ignores some historical, and Boris, what you doing there? He ignores some historical and economic facts. Facts are good. And I like facts because I think a deterministic factual component is really an excellent complement to the kind of generative components that we're seeing in modern data-intensive systems. So I like building knowledge graphs. In fact, I wrote a book about it, and there's probably still a few copies available at the Neo4j stand if you're nice to Alex Erdl. So me and Jesus wrote a book about this. We like the way that you can collect together collections of facts and arrange them purposefully in a graph so that they can be easily curated and understood and deployed in modern data-intensive systems, including those systems that have generative AI. And I work at Neo4j, so of course I like to do these things in Neo4j's graph database. So let me dip out of politics and AI for a minute and give you a quick tour of how to build your own knowledge graph. So thank you for those of you folks that came to the Neo4j stand over the last couple of days, and hopefully you already have absorbed this stuff. For the rest of you, knowledge graphs are a really simple model. We have a few basic idioms. We have nodes, round things. They tend to represent entities, things in your system. They can have labels that classify them, one or more labels. But I think even more importantly, we can have relationships between them. A highly associative model where you have many relationships between them. And each relationship has a name, a type, and it has a direction. So we can see here that the person representing Dan drives the car, and the person representing Anne owns the car. And Dan really needs to man up and get his own car since he's been doing that for 12 years now, 13 years now. So we've got a really simple model. And you can see here that you can read this as something like, Dan has a sister called Anne. Anne has a brother called Dan. You see that Dan drives this car. Of course, it's a Volvo. Yeah? I see nodding approval, right? Yeah? It's patriotic spark of Volvoism here in Sweden. And the Volvo is a V70 classic, I think, classic of the genre, and it's currently wherever this is. That feels a bit far south for you guys, but who knows? And that's it, right? That's the model. And you'll be able to use those same idioms to build high-fidelity, highly associative data structures to capture knowledge, to capture facts with the intent that you can use them, right? And in fact, it's very easy to do that from a technical perspective. Sorry, I know this is supposed to be a keynote, but there's going to be a bit of code. If I want to put this stuff into a knowledge graph in Neo4j, or any other database that supports ISO GCOR, this is what I do. I use the merge statement, which means stick it in the database if it doesn't already exist. The round parentheses, they're nodes. So here I want to merge a node. I want the node to have a label person, so colon person, and I want some data. I want a key value pair in that node, and it's going to be name Alice. And I'd like to refer to that node later, so I'm going to bind it to the variable A. I'm going to do the same again for Bob, and then this lovely thing at the bottom here says merge that Alice has an outgoing edge, outgoing relationship to the node representing Bob. How easy is that? Super easy, right? You could type that into your Neo4j console now, and it would work. And similarly, when I come to query this model, for example, here I can say, given Alice, perhaps Alice is the logged-in user, and I'm looking for where Alice has outgoing knows relationships to other people. Tell me the people Alice knows, right? Super easy. But again, you can see from using these basic patterns, you can build very sophisticated queries to understand the facts that are encoded in your knowledge graph. Of course, one thing you might do is do a social recommendation. This recommendation, initially you're like, whoa, Jim, a lot of code there. No, super easy. On the top line, you say, hey, database, find me a customer, and find me where that customer is Alice, the logged-in user. And then at depth 1 or depth 2, so friend or friend of friend, find me all the other customers. And then where the customer isn't the friend, because of course friend of friend could be me, so filter me, find all the distinct friends, and then look in their basket. So I'm looking for a friend that has bought a basket, and where that product appears in that basket. And then I've got something that looks a lot like SQL, saying, hey, return me the product, the count of the products, order descending, and give me the top 5. So give me the top 5 things that my friends and friends of friends have bought. Super easy recommendation, super powerful, because humans suck. Right? Did you want an iPhone 15? No, my iPhone 13's fine. Your mate gets an iPhone 15. Want an iPhone 15 now? Right? We are so fallible. Even Swedish people who pretend otherwise. You know it. Yeah, you're only human. Really? You are? Yeah. No? We've got some dissent in the front. Okay, you are only ice humans, after all. Now, look, initially you think, man, this is hard. Like, I know data. I've done relational stuff. I went to university and they taught me like first, second, third, Boyce card, normal form, and so on. But I'm here to tell you that actually graph data is really easy. It takes a lot of unlearning to let go of the idioms that we were very skillfully taught at university. But once you're over this hump, once you're using graphs and you find that you don't have to obey a bunch of laws that pander to the database, and instead you can build high-fidelity associative models that accurately capture your business domain, it's a wonderful place to be. Now, so much for databases. One of the other things that we can do with graphs is compute over them, right? So who suffered through algorithms and data structures at college? Keep your hands up if you liked it. All right, put your hands up if you failed it. Hey, solidarity with you at the back there. Okay, so 2 people in the room have admitted to failing it. I think that's really embarrassing because I'm chief scientist at a database company, and I did actually fail algorithms 102, something like that back in the day. I'm better now, don't worry, I've revised, I've done my homework. But one of the other things we can do is start to compute over our graph structures. They're very amenable to it, and there are a bunch of algorithms that allow us to do that. So when we're looking for insight at scale, when we're looking for nodes in a graph that are popular or critical, when we're looking for particular patterns or subgraphs that are of interest, we can compute over the graph using algorithms, typically with funny Dutch names, yeah, like Dijkstra and so on. Yeah. Have I got a reaction from a Dutch member of the audience? Dijks, thank you. It's in stereo now. Yeah. Are all Dutch people stereo? Okay, cool. So you've got a whole raft of these tools at your disposal, and you've got a bunch of software that will help you do it. So you can be able to take some data from the database, compute over it, and then visualize the results so you can get some insight into that data. And this allows you to enrich your knowledge graph with other features that you wouldn't necessarily put in manually as a user of the knowledge graph. And in Neo4j, there are 70 of these things, but the point being that these things exist, they're production quality, and you can use them now. You can just literally call a function, and the data will be computed. So you've seen the tools, or at least you've seen 2 of the major tools. What about if we apply them, right? Because we need to start thinking about how we might use some of these techniques ultimately to start to fend off some of the more fiendish elements of generative AI. And in order to get us out of the sticky situation of complex systems or artificial intelligence, I'd like to think instead about streaming. Who has a streaming subscription? Just one? Who has 3 streaming subscriptions? Yeah? Who's sharing them with the rest of their family? My mother-in-law. So look, everyone knows streaming systems, and this is a kind of meta view of a graph of a streaming system. So I've got movies, I've got people who participated, I've got users that rate movies, which is going to be one of the things that we use heavily. So for example, you've already seen Cypher. So in this case, I've got a query that says, hey, match a node, which is the currently logged in user, that's Pamela Anthony, and where Pamela has an outgoing rated relationship to a movie, return me the movie's title, return me the rating, and order by the rating. So give me Pamela Anthony's top 20 rated movies that she wants to watch, right? Cool, useful. And you can run that, and it works. It's very simple to change that and say, well, I don't just want Pamela's top 20 movies. Tell me the top 20 movies that have been rated so far. And all I do there is I omit Pamela, and it will be everyone's favorite movies, all users, right? Super, super easy, and actually pretty quick, right? Just 82 millis on my kind of unoptimized laptop to do that kind of thing, right? This is nice. It's super low complexity. It's very graphy. But if you were to try to build this kind of knowledge graph in a system that wasn't designed for graphs, it's really hard, right? Sorry to the Oracle folks. But it's really hard to operationalize that. The joins slow you down. For those of you that do relational database, which is many of us, right? You're not at all scared about the first join you do, right? Or the second. Right? You're brave when you do the first two. The third one, yeah, that's probably okay. The fourth one, oh. 5 and 6, you're going to lunch, right? Yeah. That's fine, right? That's fine because that model, that system was never designed for that kind of heavyweight join. And doing graphs in a relational system, you end up doing recursive joins, which end up being expensive. So knowledge graphs need a kind of graph-native system to do that. Now, if you've got a knowledge graph of people that are using your streaming system, then we can use that data. We can use that knowledge, those facts that are embedded in that structure, to try to solve other business challenges. One of the things we can do is be able to help new starters in the system. So when you first log into Netflix, for the first time when you bought your subscription, did it give good recommendations? For me, no. But having been a user now of Netflix for several years, I can tell you that the recommendations are still garbage. It feels like someone that isn't me is repeatedly logging in and watching random stuff. Right? I mean, I know they've got the chaos monkey, but they shouldn't let it loose on my data. But we can, for example, stop people having a terrible customer experience. We can do things like a social profile, right? So here we're saying, hey, look, we're going to match my zip code as a sort of placeholder for social profile. Zip codes or postal codes in real life aren't a good social marker, right? I live in London. In my postcode, there are probably millionaires and there are probably people struggling to make ends meet, right? So it really isn't a good marker. But for pedagogical reasons, we'll go with zip code here as a marker. So we'll be able to get zip codes. Here we've got 5 zip codes in the knowledge graph. And so now we can start to do things where we are finding users in the same zip code. We are finding in that zip code users that have rated movies, and we're finding where users have similarly rated within a distance of 2 that movie. And then we're using that zip code specific data to create a recommendation where, again, at the end in kind of SQL-ish terms, we return the top 25 movies to someone that started on the basis that it's people like you also liked these things, right? So even though all our knowledge graph is a bunch of facts, we can start to reify this kind of much more soulful, this much more lively behavior out of it. So we can start to make these better recommendations, right? And if you ran that, it would work. Has anyone got really good eyesight? Not me, I'm old, right? And but if you don't, let me help you out. That's less good, right? So look, caveat, it's running on my laptop, it's unoptimized and so on, but it's doing a kind of global query. It's quite expensive. And while it's okay to do graph queries, you shouldn't be scared about going deep in your knowledge graph and chaining facts together. Sometimes that's not the right tool, and sometimes the right tool is to compute over your graph and enrich your graph. So for example, if we wanted to look after users so they don't churn, do you know the best metric that telephone companies, mobile phone companies use to make sure that you don't leave their service? Now you're thinking it's good customer service, or it's like cheap prices, yeah? It's your mom. If they can keep your mom on their network, you will stay on their network. True story. That is so weird. I'm not on the same network as my mom because she's paying over the odds, and I would never do that. But we can look after some customers. In our world, in this knowledge graph, we know that some customers consume more than the general population or participate more than the general population, so they have outsized influence in the network, right? You see this on Insta or Twitter or so on, right? People have influence throughout the network. You don't want to lose these people. You need to look after them. So in fact, what we can do is find out who they are. So what we're going to do is we're going to compute centrality or importance in the network. We do that by creating a projection and then running an algorithm, a graph algorithm on it to compute degree centrality, and we're going to write those results back into the knowledge graph. So now we've enriched the knowledge graph by running an algorithm with a Dutch name probably on it. Dijkstra, thank you. You're going to have to teach me to say that. So it turns out in our data set that Darlene Garcia has very outsized influence, right? Like, if you lose her, you lose a lot, essentially, of other people. But this can be applied in other places, right? Who has been to London, my hometown? Lots of you, most of you, I imagine, right? Great weather, right? All right, cool. So when you're in London, did you go on the underground network, on the tube? Yeah, it's super cool. It is cool, right? The tube kind of teleports you around London in the most phenomenal way. So we worked with Transport for London, right, who are the body that oversees public transport in London. We built a digital twin, a form of knowledge graph of the tube for them. And we asked a simple question, like, if you had £1 to spend, in which station would you invest it, right, in order to keep the network running? Any ideas from your travels? Tottenham? Weird, but okay. My guess was something like King's Cross or Waterloo, because they have lots of tube lines going in and also the rail interchange for the overland network. Do you know what the actual answer is? No one said it yet. Green Park. Has anyone been to Green Park? Maybe, yeah, some of you, because it's where Buckingham Palace is, right? So it's quite popular with people visiting London. But it turns out that Green Park has the highest centrality score of the whole network. So if you have £1 to spend, you spend it on King Charles's tube station rather than on the commoners' tube stations, right? That's what we learned from that. In this case, we need to look after Darlene. Look, Darlene is an individual. Could we generalize from that? Well, yeah, actually, we can start to find communities of similar taste in our knowledge graph. So again, we can enrich the graph. So now if we see that two users have both rated a film, particularly where the rating is high, we'll connect them together and say they co-rated. And look, this I stole from academia, because academia typically has a citation graph of who's written papers with whom and so on, right? So the same kind of thing playing out here. So we can enrich the graph, and then we can simply count the triangles for highly engaged customers by running the triangle count algorithm over the graph, again, and writing that data, enriching that data in our knowledge graph. And on the other side, you can look for ranty customers, people who have influence but are trying to say, well, your system sucks. This is terrible. All I get is crappy cartoons. I want content. So we can do co-hated using the same thing. Now, once we have that, we can start to edge towards artificial intelligence. So we can take these features that are in our graphs and we can start to do machine learning on them. Because what we know from the ML community is that within reason, more features gives you a better predictive model, right? Within reason, right? And it turns out that if you have a knowledge graph, you have more features. Sure, you're used to in your relational world saying, I'll take age and gender and zip code, and I'll train a model on those kind of things to see whether some function holds true. But why not take your graph? Your graph has lots of features. You've already seen centrality. You've already seen triangles. You have neighborhoods. You have PageRank. You have labels. You have all sorts of rich metadata, rich features that you can use for free just because you have a knowledge graph to train your models. And in fact, you can even just say, compute embeddings for me. Take the topology of the graph and compute a vector from it. First time I use the term vector. We will come back to this. So predictive ML is amazing. Like, there are good, high-quality predictive ML systems out there. But I think, even here in Jfokus, right, I haven't heard anyone say it, which is weird. It seems like that generative AI has kind of sucked all of the oxygen out of the room. So LLMs are great, but they're not deterministic, right? They are generative, and they're great for creative works. But I wouldn't really want to use a raw LLM if I was working in some kind of highly regulated or compliant environment. If I was a pharmaceutical researcher, I wouldn't say, let's commercialize this molecule because the LLM said so, right? We've already seen that the LLM says that my boss is married to his cousin, yeah? So I'm not really going to trust it to tell me about pharmaceutical molecules. There's a trade-off here, right? So LLMs run at a temperature. The higher the temperature, the more spark they have, but also the more prone they are to hallucinations. So how do we kind of thread this needle? How do we get to the middle ground? In fact, how do we use all of this to stop my LLM from hallucinating? Now, as a computer scientist, I do have to issue one caveat. What I'm about to tell you will not prevent exclusively your LLM from hallucinating, but it will reduce the incidence of hallucination, right? So I've got one word for you. We've seen it several times across this conference, RAG, Retrieval Augmented Generation. But in this conference, we've seen RAG often in the context of vectors, so geometrical closeness. I think we can do better than that. So here's my crash course on knowledge graph RAG, right? So RAG today is the best way to give an LLM access, or a system comprised from an LLM and other things, access to your data. It's very developer-centric. It allows us to treat the LLM or LLMs as a component. And it's easy to get started with because, as we've seen through this conference, there are numerous frameworks that support it, and I can stay exclusively within Java when I'm doing it. Architecturally, very straightforward. So as a user, I ask a question. It goes to an embedding generator, and I get an embedding back from it. I then do a vector search for that embedding within the knowledge graph. And I don't just have to do searches for that embedding. I can actually traverse around the set of facts in the knowledge graph to try and create richer prompts, get that relevant documents and context back. I then submit to the LLM, and the reverse happens, right? But I think what's really interesting, on the reverse, we also can go through stage 3, talk to the underlying database. And some really nice things happen. So all the examples I saw here were like, hey, we've got a vector. What if we use that vector and look for things close? So we did basically trigonometry, like cosine similarity. But there's nothing to stop us from, once we've got a landing point in our graph, a document, as we might think of it, to explore the network of facts around it, to provide topological guidance, topological closeness, to be able to enrich, verify the data we're getting back from the LLM so that we don't just rely on vectors. For all I know, the vector pertaining to Apple might be close to fruit. It might be close to software or hardware computing company. It might be a record label that the Beatles own, right? Because they may be embedded in the same space, but a topology, a knowledge graph, can disambiguate that absolutely trivially. So how does it work? Well, bit of code, but not much. So look, this is my question. I'm going to submit this to my LLM ultimately. So I'm going to call a function in Neo4j. I'm going to get an embedding back from that question. I'm then going to match all of the movies in my streaming service where that embedding exists, and I'm going to look for movies that are close by cosine similarity, in this case, so geometric similarity. Remember that from a few slides ago when I said vector? Same thing, right? So I've got these vector embeddings computed. I can now use them as the integration into the LLM, so concepts in the LLM can be related to concepts in my knowledge graph. And then once I've got that stuff, I can return it to the user. Easy peasy. Now, you might say, but Jim, this is not very graphy. It only looks up, nodes in my network, and I would agree. But there is nothing stopping us from expanding that match clause to be something much more sophisticated and pattern matching, right? So we're able to do that. And in fact, we're able to do things that are much smarter than that. One of the things that we've learned in this conference, and perhaps outside, but in this conference it was mentioned explicitly that LLMs are stateless. So LLMs have this concept of kind of statelessness. You end up building sessions, and they call that few shot. You take your conversation history with you to the LLM. All good, perfectly reasonable. We were doing that when we were building RESTful services many years ago. Talked about that in 2009. But actually, what about between sessions, right? Where's the state? Can I ask my LLM to recommend me a book in a genre? Can I find, hey, LLM, what's a good book to read about graph databases? Will it tell me that? Yeah, I think it will, right? Feels normal. Probably it will recommend Knowledge Graphs by Jesus Barraza. That's what I'm hoping. Can I ask my LLM how many of those are in stock? Well, I could have trained it on that data, but training is historical, so it'll only be able to tell me. So I need to mix this stuff with real live data. I need to be able to, in this case, store my users' preferences across interactions with the system, not just the LLM. So in this case, instead of saying I want to watch a drama movie with Gene Hackman, I just want to watch a movie with actors from my favorite films, right? I need a bit of comfort. And the way I can do that is by doing a kind of level of prompt engineering, by using the facts in my knowledge graph to help me engineer a good prompt that pertains to my circumstances. If I like Gene Hackman movies, those will surface out of my knowledge graph, and I'll be able to use that as a way of parameterizing my interaction with the LLM, and hopefully then get better interaction with it. And then, of course, on the way back, I will be able to straighten out any lies and falsehoods in the knowledge graph and return good quality recommendations to my user. This, by the way, is happening. This isn't just me trying to flog you the idea of graphs and LLMs. This is a thing that is happening. This is a paper that is on arXiv, so it's not peer-reviewed yet, but it's well worth a read, written by Juan Sequeira, who is quite a famous person in the world of graphs and semantic modeling. And what Juan and his collaborators did is they built a RAG-based system. They looked at how it performed. They found that if they used a SQL system, it gave them about a 16% uplift in accuracy compared to a raw LLM. They then changed that to a knowledge graph-based system, and it gave them a 54% increase in accuracy compared to a raw LLM. So this is really interesting, right? This is a thing that can provide significant benefits to you folks that will be using LLMs in your day jobs in the future. On the subject of the future's unwritten. Like, LLMs are going to be useful. They've only been around a year and a bit. We don't yet know the true extent of their impact. We are seeing patterns like RAG. We are seeing patterns like training an LLM exclusively from a knowledge graph to try and keep it on the rails in terms of facts. For regulated environments, we've seen the use of LLMs to do corpus ingestion and then spit out a knowledge graph which can be used to transparently and deterministically answer questions. But where this goes from here, I don't know, right? It's exciting, it's moving fast. But I do know people that have opinions about this. I'd like to talk about the work. In closing, I'd like to talk about the work by Yejin Choi. I mentioned her earlier in the talk. Professor Choi is a researcher at the University of Washington. She's really interested in LLMs. In fact, Choi is the recipient of a MacArthur Grant. For those of you that don't know, MacArthur Grant in the US has the nickname the Genius Grant. Right? It's only given to like mega brains, far above my standard and possibly far above even most people in the room. And what she and her team have been wondering about is, can you make LLMs better? And one of the ways they've been trying to make LLMs better is by talking to them. So in this case, kind of a Socratic reasoning. And in one of the projects she did, she said, I'll ask the LLM some questions, and then I'll ask it the inverse of those questions, and I'll see what happens, right? Because it should work, right? If you travel west far enough from the west coast, you will reach the east coast. If I go west from the round, yes, that's true. That makes sense to me. It also makes sense to this person. Next question: if you travel west far enough from the west coast, you will reach the east coast. Well, false, because you can't reach east by going west. Okay, so it's got it wrong there, right? Even though you've just asked it a similar question a moment ago. The Earth's round. If you travel in any direction long enough, you'll return to where you started. True. The Earth is round, and if you travel in any direction long enough, you will not return to where you started. False. Okay, I think that's fine. And so on. So she's starting to do this Socratic reasoning with the intent of picking out places where the LLM is self-contradictory or failing. She builds on this, right? So she builds on this Socratic reasoning, she and her team, and they're like, okay, look, what else can we do to help here? Can we start to think about common sense? You know, that kind of east to west thing works really easily for humans because we understand the kind of non-Euclidean geometry of the Earth. But it turns out that capturing common sense for a machine, even a generative AI, is really difficult. For example, it's okay if you leave the living room door open, right? I mean, it might be annoying to your partner, but it's okay. No real damage done, probably. Is it okay to leave the fridge door open? I don't know, man. Like, doesn't feel like, I mean, it's cold here, so you'll be fine, right? But in general countries that have a temperature differential between a fridge and the living environment, it's not fine, right? Your food will spoil. But it's really hard to teach that to machines. So what they're doing is they're trying to disambiguate between language models and knowledge models. Sound familiar? It's something that I'm rather keen on too. So in fact, what they're doing is creating knowledge graphs of these models. And when they find that they use knowledge graphs to answer questions generated by LLMs, but ultimately scored by humans, these models are 16% better than a raw LLM. And in fact, now they've gone even further. So the new techniques that they're looking at is this idea of symbolic knowledge distillation. Symbolic knowledge distillation, again, involves multiple AIs. It involves a large language model, one of the big ChatGPT models, for example, and a critic model that kind of criticizes the output from those. And the output from the critic is used to create a knowledge graph, right? A graph of facts that have been vetted by another AI. So probably okay, or overwhelmingly okay. And it creates then, and we use the knowledge graph then to create another model, to train another model that's both smaller and better. I think in a data pipeline of the future, this is going to be commonplace, right? This is a knowledge graph that's at the heart of your data pipeline. It's inspectable, it's curatable, and it can be created, in this case, by Roberta, right? So what they found when they did this was they found that the combination of the teacher being criticized by another LLM, Roberta in this case, could lead to a smaller and higher accuracy model, which is phenomenal. And I'm watching this stuff closely because I think it's fascinating, and where Choi and her team lead, the rest of us will follow. So let me sum up. We're going to be building data-intensive systems. They're going to have LLMs in them, right? That ship has sailed. We're all going to be exposed to this stuff. But my thesis to you folks is that if we're going to be building systems based on LLMs, we need a counterbalance to them, right? We need a deterministic, transparent counterbalance to the generative, opaque system that is the LLM. And my thesis is that knowledge graphs are that because they're curatable, they're human inspectable, they're deterministic, and they're lovely. It also avoids, or helps to avoid, the Boris Johnson problem. As developers, we can get started with this quickly. We've seen a whole bunch of stuff during this conference around LangChain4j and so on, but the Docker folks have produced some middleware called the GenAI stack. So if you want to get going with this now, like literally go with a Docker container and run, grab that, and you are off to the races. And it's just left to me to say, thank you, folks, so much for making this such a warm and lovely conference to come to. It's been a pleasure mixing with so many of you over the last few days. I hope that this talk hasn't put you off coming again next year. The Dutch folks get free tickets, right, Matthias? Something like that. But thank you all. Have a great evening. Safe travels home.